Hey everyone, this is video 7, and here I will be talking about polyatomic ionic nomenclature. Okay, so in this case, we are going to have some of our ions that are formed in the ionic bond being polyatomic ions. And you should have in your notebook a list already of those polyatomic ions. We practiced them on Quizlet. You should have them memorized. Some examples are like nitrate is NO3 minus. Could have ammonium. This is one of the few positively charged ones, NH4 plus. We could have like phosphate, and that is PO4 3 minus. So feel free to have your notebook open with this list, and then as you get better at it, you'll probably memorize it. But for now, you can refer to that list. So let's say that I have a compound that says iron 3 phosphate. So you should recognize right off the bat the name of the polyatomic ion. That should tip you off that one of these guys is involved. Remember that when we have Roman numerals, that's indicating a transition metal that can have more than one charge, and it's telling you what the charge is. So iron 3 is going to be Fe3 plus, phosphate is PO4 3 minus, and the plus 3 and minus 3 charges crisscross and they cancel each other out. So that will be FePO4. Now let's say we did iron 2 phosphate. That's where it gets interesting. In this case, we still have our PO4 3 minus, but it's iron 2 plus. So when we crisscross the charges, they do not cancel out. And we are going to have to put our polyatomic ion in parentheses in order to make it all cancel. Because the point of this is electrical neutrality. You have to have the correct number of each of these polyatomic ions, the correct ratio, so that they have a neutral overall charge. Otherwise, they're violating that rule, that overall goal that atoms have when they form bonds. So the +2 comes over here, 3 comes over here, and we end up with Fe3 parentheses for the polyatomic ion PO4 2. Okay, and that is the formula for this compound.